In this lesson, we're going to be learning about signed area. So let's begin with an example and you'll see what this means. So we're being told that in the diagram below showing y equals x squared minus 4x plus 3, we want to find the area bounded by the graph x equals 0 and y equals 0. So here is our graph, and what this is right here, this is what we're being told is y equals x squared minus 4x plus 3. So let's just label that. This is y equals x squared minus 4x plus 3. So this one right here. We also need to find out, we want to find the area bounded by the graph and x is equal to 0. So let's put x equal to 0 into this thing. So it's simply going to be right here. That's going to be x is equal to 0. Let's label that. So that's going to be x is equal to 0. And the other one we have is y is equal to 0. Let's also label that. So that is going to be here. Y is equal to 0 right there. Okay, so let me label that. That's y is equal to 0. Now, it's the area bounded by the graph and these lines. So it's going to be here. And also the area bounded, let me see if I can do this nice and neatly. Also the area bounded right here. If we keep going up here, you can see that this isn't bounded anywhere, but this region right here, this is a bounded region. So let's highlight that. It's quite clear that this is bounded by the graph and y equals 0. And this one here is bounded by the graph, x equals 0 and y equals 0. So these are my bounded regions right there. And what we need to do is we need to find the area there. So what we're probably going to have to do is find out what these intercepts are. So let's just do that now. So kind of implicit in the question is find these intercepts. How are we going to do that? We're going to have to factorize this thing right here. So we have y is equal to x squared minus 4x plus 3. Well, if I factorize it to be y equals x minus 3, x minus 1, that's going to work because negative 3 times negative 1 is positive 3, and if I add them together I'll get negative 4. So therefore my x-intercepts are going to be they're going to be 3 and 1. So let me write this as x is going to be equal to 3 and 1. I can come over here and say this is going to be 1, or rather this will be 3 and this one will be 1. So just like that, we've done it. Okay, so now we want to find these areas. Well, in the last lesson, we learned how to do this. So you might be thinking to yourself, this question isn't that hard at all. In order to find these areas, I just have to do the following. So we're going to see what happens now if we do this. What happens if we find the definite integral of our function between x is equal to 3 and x is equal to 0. So as you can see here, and that's because, we've got x is equal to 0, we've got x is equal to 3. So that's the region between this point and this point. That's where things are bounded. So we're not really paying attention to the fact that we've got a bit above and a bit below. We're just going from here to here, and we're going to see what happens. So this is exciting. Let's go. So the first thing that we do when we have a question like this is that we anti-differentiate the function. So that's going to be x cubed over 3 minus 4x squared over 2 plus 3x. And then I put that in brackets and I put my terminals on the outside just like that. Let's just clean this up a bit. I've got 4 and I've got 2 there. So this is just going to end up being 2. Now what I'm going to do is I'm going to sub in my upper terminal. So it's going to be 27 over 3 minus 3 squared is 9 minus 2 will be 18. And then on this side I'll get 9 because 3 times 3 is 9. And then I'm going to subtract what happens when I sub in my lower terminal. Well, that's just 0. So I'm just going to get 0 there. No point in subbing that in and wasting our times. So let's keep on going here. 27 over 3 will be 9 minus 18 plus 9. Well, I've got 9 plus 9, which is 18, and then minus 18. So it's going to be 18 minus 18 is going to be 0. So, okay, that's a bit odd. It seems that what this is telling me is that the area bounded between 0 and 3 is 0. The area is 0. That's clearly not true because I've got things here and I've got things here. Like if we label this as A1, there's something here, and I've got this as A2, there's something there as well. Clearly I don't have 0 area. What is going on here? Well, let's just leave our confusion there for the time being. And instead of doing it all in one shot, as you can see there, we just went from 0 to 3. Instead of doing that, what if we instead went from 0 to 1, and then we went from 1 to 3? So let's do that instead. So we're going to rewrite it now, but we're just going to solve for a1. So we're going to find the area of a1. So we're going to get the integral of, my upper bound will be 1, my lower bound will be 0, because I'm going from this point to this point. I'm still anti-differentiating x squared minus 4x plus 3 dx. And obviously when I do this, I'm simply going to end up with the same derivative, antiderivative as I did over there. So I'm going to get x cubed over 3 minus 2x squared plus 3x. I put my terminals in. I now am going to sub in my terminals, starting with my upper one. So it's going to end up being 1 over 3 minus 2 plus 3, and thankfully we have a 0 here, so it's just going to be subtracting 0, so I don't have to concern myself with that. So I'm going to end up with, this is going to be 1 over 3, this is going to be 1, and I'm just going to immediately write that as 3 over 3, because then, whoa, that's an ugly looking 3, I can just go, that's going to be 4 over 3. A1 is going to equal 4 over 3. I even put a fancy 4 there. Did you like that? All right, there we go. So that means that the area here, so let's write this in, A1 is going to be equal to 4 over 3. So even more so, you know, this number is looking even more sus. I mean, how on earth did we get 0? Hopefully you're still thinking that question. Okay, so now what we're going to do is we're going to find the area of A2. So let's come over here. We're finding the area of A2. So what we're going to do is find the definite integral. What are our boundaries going to be here? Well, it's going to be from 3 to 1. So let's come over here and let's put those in. So it's going to be 3, 1, and then I've still got x squared minus 4x plus 3 dx. So I'm finding the definite integral of this function between x, with respect to x, between x is 3 and x is 1. So a2 is going to be equal to, do I want to cheat here? No, let's do it. Let's do it step by step. So I'm going to get the same antiderivative. We know that. So it's going to be this, 2x squared plus 3x. Close that off. And this is going to be 3 and 1. And now I'm going to go a2. This is going to be equal to, I'm now going to sub 3 into this. That's going to be 27 over 3 minus, this is going to be 3 squared is 9. This is going to be minus 18. Actually, we already know what this is. I don't know why I'm doing it again. We could have skipped this because we know what happens when we sub 3 in, but we're doing it anyway because you know what? We're dedicated. We're in this for the long haul. Minus, now this is going to be, we know what happens when we sub 1 in, so we technically could just look over at our other working and do that, but you know what? We're here, so why not just do it? And hopefully as people look back on this working later, they'll be like, oh, that's how he did it. I'm just talking to myself here as I go through the working. So we know that all of this is going to end up being 0 because, well, let me just write it out. 27 over 3 is going to be 9 minus 18 plus 9. So hopefully that working right there shows you it's going to be 0. And this right here is going to be minus, let me keep that here, it's going to be 1 over 3 plus 1, like that. And we spoke before, because it's plus 1, I'm just going to write that as 3 over 3, because 3 over 3 is 1, and it's going to allow me to easily plus these together. So I'm going to get A2 is equal to, I'm going to get 0 in this bracket, minus this right here is going to be 4, 3. And because I've got a minus there, my final answer is going to be, oh, it would have been nice if they were lined up, but you can't have everything in life. A2 is going to be negative 4 on 3. Okay, so what is happening here? So what I'm saying, if I come up here now, what I'm saying is that A2 is equal to negative 4 on 3. So this right here, this area right there is negative 4 on 3. This one is positive 4 on 3. Why is this happening? The reason why this happens is because if we have a region under the x-axis, it's going to be negative. If we have a region above the x-axis, it's going to be positive. So what happened is when we found from 0 to 3, they cancelled each other out. Now we still give this a name. What we call this is the signed area. So the signed area of what we've just found was 0. That's the signed area. The signed area. Now, we don't often want the signed area. Of course, if the question asked you for it, all you're going to do is actually find what happens when they cancel each other out. But most of the time, what we're after is the total area. We're after the total area. So if I was to come over here for a moment, and let me write it up here. Most of the time, we're after the total area, and questions are going to ask you to find the total area bounded by certain things. To find the total area, what you're going to do is say A1 minus A2. Now that may seem odd because it looks like we're subtracting them from each other, but that's actually not going to happen because when we put in our values, what we're going to end up with is 4 over 3 minus 4 over 3, which is going to be equal to 4 over 3 plus 4 over 3, 4 over 3 plus 4 over 3, which is going to be 8 over 3. And that is going to be our answer, 8 over 3. That is what we call our total area. So what happens when we plus them together? So you need to be aware that you need to sometimes chuck a negative in there in order to counteract the negative area, which is under the x-axis. And with that, we have done our very first example. I might pause the video here, and in the next video, I'll go through another example. Hopefully this was helpful and it has made sense about what signed area is, what total area is, and all of that. With that, I'll leave you and I'll see you in the next video.